Hello and welcome everyone, this is Dmitry. We are having another network programmability stream and today we are going to explore Terraform. We'll see how we can provision infrastructure using this tool developed by HashiCorp. Um, Now, disclaimer, I have never used this tool before and no one really showed to me why I should use it like around me. So I I'm going in blind here. We will see how it will work out. Um yeah, I don't know what to expect. I am not 100% sure how it's applicable exactly to network automation and if it can be applicable. You'll see. And along the stream, you will probably hear like some of my thoughts. Be aware that they may not be correct simply because I don't know tool good enough to like provide facts, but I will be sharing with you like what I think so far and stuff like that and how I understand things that I see. So yeah, we'll see. Usually I know something about the topic. Now this time I completely don't. I guess whatever. It's a good time to learn. Okay, couple of topics to discuss before we start the main topic. First of all, there was there was no stream last week, but there was stream 2 weeks ago on my network automation controller, which where we did a lot of great progress. Something I'm still proud of what we built last time. That stream was not published yet. I am kind of slacking on that. To be honest, the reason why is that I also want to record a small GIF, like showing how that piece works, and when I'm going to announce that the recording is up, I want to include that GIF to show people what it's doing. So like it takes time, unfortunately, and I kind of didn't do it so far. So yeah, last time we built this controller, which on the web page, if you go to a web page, it builds a network diagram using LDB information, and it builds it live within like 2 seconds or so. So like you go to a web page, it goes to all devices via RESTconf, gathers LDP data and builds a diagram directly in the browser, and that is happening lightning fast. I was very proud when we got it to work. It still obviously requires some tweaking, but yeah. I hope I will publish this early next week. Um, we'll see. Next is I stumbled upon this interesting piece of content. If you are a Python developer, I recommend you watch this content as well. So there is this guy, Harry Percival, and there is a recording talk for Python 2020 called Stop Using Mocks. And it talks about tests and Python software architecture. I watched this. I watched it. I was very impressed. I learned some tricks there, and I see how I can apply some of these techniques to my code. So yeah, I can recommend this talk to everyone. This guy also wrote a book, Cosmic Python, which is already released, I think. And you can either buy it or you can read it for free on his website if you cannot support the author via other means. So yeah, check this out. To be honest, I didn't have time yet to go through this. But this book is on top of my list. It's probably going to be the first book that I will finish. Like it's on top of my list that I'm going to read. So yeah, because I want to become a better Python developer and write better, more maintainable code and stuff like that. And last thing that I wanted to cover was so apparently one of my videos got claimed. Uh, and it's kind of weird because I use DRM copyright-free music, and there was some how it's called label or something that came after my video claiming that I used a piece of song that was theirs or something. I don't know. I didn't dig too much into that, but I was very surprised to receive something like this, considering I use pretzel rocks all the time. This is my source of the copyright free music. I know, kind of weird, but whatever, I guess. All right, let's jump into today's topic. And folks, if you like know more, or you see me doing something stupid or whatever, like, and you know that, okay, you can actually, like, I'm not telling the truth or something, because like I don't know this topic very well, right? I don't know this topic at all, so I may make mistakes, so feel free to correct me if you are more familiar with the tool. Um, as of right now, of like me jumping into this unknown, the way I understand Terraform is the following. It's a tool which allows you to declaratively um, describe infrastructure with some kind of declarative file. Think like Ansible, Ansible data files or something, right? Kind of like that. And it's mostly related to either cloud providers, um, like I don't know, GCP, Amazon, or something like this. I guess it's not only for cloud, but I don't know. I saw mostly people using it for cloud. So like you can describe in a file that I want X number of, I don't know, virtual machines with this configuration in GCP, and then you do a single command and it will do it for you. Um, I'm pretty sure, yeah, I'm pretty sure it's you can use it outside of the cloud. Just I I don't know how it is applicable to other pieces, I guess. Like, and in terms of network automation, this is like even less clear to me. Like, I don't even see a use case for Terraform. Maybe I'm wrong here. Um, so yeah, this we'll see. Okay, so I don't even have a single like blog article or something. So you'll just go to their website. I think I will want to start with a CLI. I want to download CLI here on my computer. Um, okay, so let's start by downloading it. I have here my VM. Hopefully that works. Let's update this as well. And if you folks know about like how it can be used to work with network infrastructure in particular, let me know. And if you also know some kind of, I don't know, blog article or something on that topic specifically, also share it in the chat. So yeah, so that we could explore together on the stream, I guess. Because as I told, as of right now, I don't see how it's directly applicable for network infrastructure. This takes a while. Okay. So let's download this. excuse me. Do I have unzip here? Yeah. And do I have a bin folder? I do have a bin, okay. Okay, cool. We went through this. Let's go next. Please maximize window font is less visible. Sorry, I mean, the only thing I can do is just increase font here a little bit, but I cannot maximize the window right now. Haven't really used Terraform for network stuff. I know there is an ACI provider, but I don't really think it's a great tool for that. There are some other use cases that may make more sense. For example, F5 firewall stuff could manage service type with application deployment. Okay. Tell me more about how it would apply to firewall, for example. Are we talking about creating ACLs with API or something? Okay, here I also have my Google Cloud account that I use on the stream. So we'll probably go through this. Duration 65 minutes. Say you're deploying a web app or something. Yeah, exactly. You can deploy CL not configs and manage those in tandem with the app you are deploying via Terraform. Okay, for that, I guess you need to have. I'm thinking. Do you need to write a provider on your own, or is there are providers like this for firewalls? Because you need to the tool needs to understand how to interact with API in idempotent way, right? Like, okay, I have this ACL or I have this object or something, and then I change something for my application or I deploy a new one or whatever, then it needs to be able to talk to device via API, but it also needs to understand how to keep state of that object. The responding firewall provider. You know what? Let's actually start going through that. Terraform providers. Okay, there's Cisco ASA, Cisco ACI, Cloudflare, Cloudflare. What else? Heroku. Yeah, I will check right now. Cisco ASA, DigitalOcean, DNS, Simple. Okay. Is there really a provider for how it's called? Hurricane Electric or HEDNS? No. Okay. Terraform. Terraform can work with Terraform. Terraform Cloud. Okay. Octa authentication service, F5, Docker, Nomad. Nomad, by the way, so I was thinking about this stream topic and my choice was either this or Nomad. I'm also very interested in exploring HashiCorp Nomad, probably some other time. Mainly if you have to do a container cluster on-prem, building your own Kubernetes cluster and managing that is kinda not fun, I guess. It's a little bit convoluted, so I was thinking if Nomad could help me with that. So yeah, probably one of the next things will be about Nomad. Okay, ATN networks. Okay, so I see cloud providers. I see some DNS stuff here. I see CDNs. Do I see? Yeah, I do see CDNs. Some DNS, authentication, some networking. Well, mostly around firewalls and load balancers here. VMware stuff, which kind of makes sense, I guess. So you can deploy VMs on your infrastructure. Fun. And also GitLab, GitHub, Bitbucket. So also version control. Okay, so I guess I will go through Cisco ASA and like see what you can do here. Okay, so Cisco ASA provider is used to interact with Cisco ASA hardware devices or ASAv. And you give API, URL, username, password. Oh, okay, and then there are resources. You can have ACL in, ACL out. So yeah, folks, if you look on something like this, right? I mean, what this release is a declarative description of what you like want to do. Like think of in this particular example, this is say right. Many people use Ansible, so something like this would be in like your host vars or in your host vars file or something, right? It's the same thing. It's just a little bit different format. I don't even know how this format is called. But yeah, it's like, and now think about something like this and now apply this to cloud providers, right? Like, I'm thinking maybe even I should do it with network stuff. It's HSL format. HSL format, let me see. Oh, I cannot find any resource that could explain this abbreviation to me, I guess, whatever. Okay, I have no problem with this type of format. To be honest, like, I'm thinking, this is actually nice, I guess. Like, YAML with its indentation is weird. This one also has indentation, but I guess it's a cosmetic one because we have these braces. Like in YAML, so easy to somehow screw up the level. And then I'm thinking, like, are there really alternatives to YAML to store the data? And honestly, nothing comes to mind. Like something that humans can interact with. Like JSON is not really an option. Yes, it's like structured and stuff, but it's not really human readable. XML is even worse. Then TOML, not really great when your data get nested too much. It's great for flat or close to flat structure, but when the data gets nested, it's kind of weird. So to be honest, this looks fine to me. But HashiCorp sounds something like it. Okay. Okay, so we have access listing, access list out. What I'm curious about is that with this, will it do what it will do if there is an access list which is not one of these? Will it just delete it? This is how will it guarantee idempotencies this way, or I don't know. Okay, so we have ACLs. This is kind of weird. What is the difference between those? This one is on interface, but then why we are declaring the whole rule there? Networking object. Similar to JSON a bit. I wouldn't call it very similar to JSON. Like JSON is really not human friendly, I guess. This one is quite human friendly. Um, but yeah, there is some resemblance, I guess. Network object. Okay, folks, I think we would want to see this, but probably not as like probably after we go through like typical use case. Like I want to be able to see how here, yeah, here is the thing that I want to achieve by after the stream. Understand the tool better. When someone tells me like, okay, we are using Terraform to do this and this, like I understand exactly what they're trying to achieve and why. And then see if it has any relevance to network engineers or network automation engineers, I guess. Yeah, I think those are my goals for today. So because of that, I think it would make sense to go through a use case, so, like through some of their labs here. And then later go like apply it to some kind of networking stuff. Yes. So let me think if I should spin up my viral. I think I should. Yeah. I will just let it load. Right, let's go to the lab. Um, okay. You will use Terraform to provision, update, and destroy set of infrastructure using sample configuration provided. Okay. You need GCP account. A system with Terraform installed. Okay, I have both of these. You also need. This also is interactive to the Google Cloud Shell. No, I don't want to use Google Cloud Shell for this. I want Terraform. Okay, we don't care about video, installing Terraform, and we are done with that. Okay, let's dive right into it, create some infrastructure. We will build infrastructure in GCP for getting this, for getting started guide, but you can do other things. We already explored providers. Okay, GCP project. Okay, we have a project here. You know what? Let me first see if I killed my Cloud Run. By the way, folks, like I think around 4 months ago we had a stream on Cloud Run. I was very impressed by Cloud Run. I really liked it. So yeah, just letting you know, if you haven't seen Cloud Run and you are deploying applications in any way, I suggest you take a look into that. Okay, unique project ID later. You need to enable Google Compute Agent for your project. I think I have this. Let me see. Yeah, I have it enabled. And you need GCP service account. Terraform will access your GCP account by using service account key. Create one now in the console. Um, Project editor. Okay. Okay, folks, I will switch the screen for a little bit so that you know, I know that some internet people have malicious intent, so I really don't want to wake up tomorrow in the morning and see my GCP account and my credit card getting charged for 10,000 bucks. So give me 1 second here. But I can at least talk through what I'm doing right now. So after I clicked on that, I got a JSON file, which I'm right now saving to my computer. And I guess I will have to send it to my virtual machine. So this is what I will need to do. Well, let me think if that could be dangerous. I think I should be fine. We should be fine. Okay, 1 more minute, folks. I'm trying to. I forgot how I usually send files. Oh god. Okay, I think I'm good. So let me switch my screen back. All right, you should be able to see my screen again. And if I go to GCP folder, I have this file. So this was a file that I could download with private key. Yep, and I think this is all we need for Terraform. Okay, so we created a key. Okay, you need to create a set of files to describe infrastructure. You create Terraform configuration. Okay, the format is documented somewhere. Okay, so syntax consists of few basic elements. Block type, label, another label, identifier expression. Following simple example describes a simple network topology for AWS, just to give a sense of overall structure and syntax of Terraform language. Okay, so you have a variables. And okay, it seems like this variable is like a namespace here. And then you have, or no. No, this is actually a variable itself, but the variable can have description, some kind of value, you can even have a type. And then you say provider AWS, where you can define some other thing. Region is equal to var. No, it's weird. You can have some functions here. Remember I told you that it's kind of simple, human readable? No, it's not simple. What is this Python code is doing here? Jesus Christ. Wow. Okay. I'm looking this is not easy to me. Okay. Okay, create a directory for the examples in this guide, and inside of it save the example configuration as main TF. Terraform recognizes files ending in TF or TF-JSON as configuration files and will load them when it runs. Okay. All right. Okay. Provider Google version, whatever credentials. Okay. Hey, they ask me for my credentials. So, and project ID. Okay, and this creates VPC here. So let's go to VPC. Where is this? No, I don't. Is it in zones? No, it's not. Where do we create networks? Okay, well, I have here US Central one. Okay, I'm not sure this creates anything, but we'll see, I guess. And probably there should be some explanation of what we are doing. I hope so. Okay, provider is used to configure the named provider. Okay, it's Google. I think another helpful thing would be to open the Terraform provider. So like I have a reference which I can check things. Okay. Provider block is used to configure the named provider. In our case, Google. Provider is responsible for creating and managing resources. You can have multiple provider blocks. Resource block defines a resource that exists within the infrastructure. A resource might be a physical component, or it can be a logical resource. In this example, we are creating a network for the resources we'll create later in this tutorial. The resource block has two strings, the resource type and resource name. Okay, so this is a resource type and this is a resource name. The prefix of the type maps of the prefix of the type maps to the provider. In our case, Google Compute Network automatically tells Terraform that is managed by Google provider. Okay, the resource type and name together form the resource ID. In this case, Google Compute Network.vpc network. Okay. Within the resource, there is a configuration. This is dependent on each resource provider and is fully documented within our provider reference. GCP provider documents separate resources, including Google Compute Network. Manages a VPC network or a legacy network resource on GCP. Name of the resource. Okay. Cool. The first command to run for a new configuration is Terraform init. Okay. Okay. So Terraform plan. Okay. So first it saw that our Terraform script is using a provider, Google, that is not that is not installed, right? So then it went ahead and installed it. I think this is pretty nice touch. Then we used plan to understand what it's going to do, I guess. And that I guess if we apply, we'll create a VPC network called Terraform network, right? In US Central 1, US Central 1C. And it will have these parameters, which I guess are defaults. No, not to reply. Please specify out parameter to save this plan so Terraform can guarantee that exactly these actions will be performed if Terraform applies subsequently run. Okay, so one interesting, well, one thing that like I don't know yet, like just based on this message, it seems like I actually don't know if it's true. It seems like it actually went and used our GCP key to like see what needs to be done to make infrastructure, to make this resource available, I guess. Like I want this Terraform network to be there, right? So I guess it went ahead and checked it when I ran Terraform plan before showing me this. So this, I guess this is why they say that this, right? So then because you didn't save this, then when you run Terraform plan again, it will go again to Google and it will not use this result here because maybe someone already went ahead and created this, right? I guess. Just interesting. They actually don't say Terraform plan here. Earlier versions require using Terraform plan. To see the execution plan, use Terraform version to configure your running version. Okay, and then you can just apply this using Terraform apply. Okay, so first it will ask you, okay, do you really want to do this? It's your last chance to say no. That is all pretty straightforward. Let's go. Okay, so it errored out. It seems like there is an extra space here. So let's fix this. Oh yeah, there's definitely an extra space. Let's go. Yes. Okay, another interesting thing is this like error message itself. Like, I mean, this regular expression is just nuts, but at least it gave me exactly an error, right? Like, it was an error from directly from the Google API, and they went ahead and took that error and show it to me. Now think about something like Ansible, which will just say some random thing like, oh, couldn't connect or something, connection error or something, right? Or whatever. At least this is clear on what's going on here. Like even this small touch with putting your value in the quotes so you can easily spot problems like extra spaces here. This is kind of nice compared to Ansible. You know, like there can't be a single stream without me bashing Ansible, so I just had to do it. I had to use this moment. Okay, is it here? I mean, just okay, and then there is like this like progress, letting you know that okay, I'm still alive. I'm still alive. I'm doing the work. Uh, and here we go. Here we have our Terraform network, Terraform network VPC, which is nice. Um, okay, let's keep going. Okay, this is nice so far. You can go to GCP console already. One step ahead of you, guide. Okay, if you look in the current working directory, you'll see that Terraform also wrote some data in Terraform TF state. Okay. The state file is extremely important. It keeps track of Terraform understanding of the resources created. We recommend that you use source control for the config files, but the state file should not be stored in source control. You can also set up Terraform Cloud to store and share state with your teams. You can expect the current state by showing Terraform show. Okay, I think showing this was a mistake, but I guess I'll have to delete the key anyway after we're done with the stream. Okay, so I guess it's like, how to put it? It kind of like cached the current state of the network, of the well, of the resource in this case. It's kind of like you said, okay, I want to manage VPC network called Terraform network, right? And then it caches state that okay, currently this network already exists, right? So I guess if I do Terraform apply again, I want to see what's going on. Okay, interesting. Yeah, you see, it's checks the state again. Okay, you know what? Let's apply some. How do I kill it? I just want to delete it, and I want to see how Terraform, like what's going to do. What are you going to do, huh? With me deleting your network. Let's see. Okay, let's wait first for this to finish. Okay, so far I think I like what I see. I, start getting some understanding of what's going on here. And I know a lot of people use Terraform if they're using some kind of cloud. Can you please just get deleted? Okay, so network was deleted, right? Now I want to go ahead and see Terraform show. Okay, it still looks at that state file, right, and says, oh, okay, it's still there. But I'm curious now what is going to happen when I say Terraform apply. Okay, awesome. Okay, so it actually, when I do apply, I think what it did the first, it refreshing the state. So it went ahead and looked at this resource, networks Terraform network, and saw if it exists or not, right? It didn't exist, so now it proposes us to create it again. Very nice. So it can like guarantee that. So this is actually seems like to be idempotent, and this is not like. Is this? Oh no, never mind. Never mind. What I wanted to say, I don't think it's applicable. See, in the cloud world, there is not many problems with idempotency. Everything is exposed with mostly crude API where you can like manage any resource you want easily. You can like update it, delete it, whatever. It's not the same as our network infrastructure usually. So I'm still laughing when people say about like important network configuration is Ansible. Yeah, right. Of course. Okay. So our resource should be back. So if I refresh this, I'm pretty sure it's going to be the next thing in the guide. Because like stuff like this is a critical of understanding the tool itself. Like why would you want to use this tool, right? So at least, yeah, at least. Oh, excuse me, I didn't sleep very well today. You can inspect the current state by running Terraform show. Okay, we already did that. Okay, next, change infrastructure. The previous page you created your first infrastructure with Terraform a VPC network. This page you are going to modify your config and see how Terraform handles change. By using Terraform to change infrastructure, you can version control not only your configuration, but also your state, so you can see how infrastructure evolves over time. Okay, so this is also kind of interesting what they suggest here. So you can either not add it to like version control, I guess. Yeah, so this the state files that we saw, right, allows you to see like this or actually this underlying JSON, right? This file, by saying it, you have a snapshot in time of how your infrastructure looked from Terraform perspective, right? So then if something happens, you could not only see your like desired change, but you could also see the outcome of that change saved. It's kind of like saved artifact of your infrastructure. Interesting stuff. Okay, you can add new resources by adding them to your Terraform config. Oh, so sorry, folks. I'll probably keep yawning for the rest of the stream. Okay, first add a Google Compute Instance resource to my ETF. Okay, and before we'll do that, we'll go to Compute Instance, VM instance. We'll go to VM instances. I don't think I have any VM instances here. Yeah, I don't. So yeah. Okay. So we are still using provider Google, but now we are using different resource called Google Cloud Instance, and then we have VM instance, and this is the smallest one, Debian Cloud Debian 9. Now I guess I want to check if Google still has that image. So yeah, one thing I really like to do, folks, is to like when I'm going through any kind of tutorial, I would take the tutorial and I would slightly change it, kind of to, and it helps me learn this stuff and understand this stuff better. So this one micro. Interesting. What is container image? Okay, so if your VM is running mostly containers, then I guess you can use this. Okay, so what I'm doing right now is that I want to see, I want to see the tags. Okay, so there is Debian Linux 10, right? So probably let's change this to 10. And probably we should ideally find tags here somewhere on Google page, so we know exactly what tags there are available. Probably, you know what, it's worth checking out. TCP image tags. I guess there is some kind of API page, API endpoint, which will allow us to see what tags are there. Okay, so what else is here? So I am using Debian 10 here, and there is network interface, and then it's going to use Google Compute Network, VPC network.name. Interesting. Oh, okay, so network interface, I think, is going to be named like this. And then access config. Oh. Okay. Okay. Network interface. Access config 0 not IP. I don't see this resource, to be honest. Maybe it's later here. Okay, here. Network interface block supports network name or self-link with a network attached to this interface. Okay, network of the interface. Okay, so this is now it kind of makes sense that we are referring to this one. And then we have what access config. Access configurations, for example, IPs by which instance can be accessed by internet. Okay. This resource, okay, it's the same thing, and you can see it in the docs. this will be connected to VPC that we created. Notice this configuration refers to network name, property via Google, compute network, VPC network name. Okay, so this part is ID of resource, and then on this resource you can access some of these things like .name. The presence of access config block, even without any argument, ensures that instance will be accessible over the internet. Now run Terraform apply to create a compute instance. Okay, let's go. Oh, I didn't save it, of course, but of course. This will take a while, I guess. It was faster than I thought it would be. So I think we should be able to see our VM here. Which we do right now. So there is Terraform instance. It has an IP here. It has internal and external IP, so I can connect via SSH to it. I don't think I have SSH key for Google Cloud on my VM right now, but I should be able to access it via SSH here. Yeah, I don't think this will allow me to do root. Unlikely, very unlikely. Oh, this instance is slow with 600 max of RAM. Slow. Wow, it's still showing. Yeah, connection refused. Okay, and okay, this is very interesting. So not only it created, right, the VM, but it also queried it back to get stuff like instance ID, to get stuff like some details about boot disk, but most importantly is network. Like you can now have network interface access config not IP network tier premium. Okay, so you can now programmatically refer to this IP address because it queried it right after it created the thing. So this is quite kind of cool. So it not only kind of controls that this resource is present, but it also makes sure that like it queries some of the details of created resource. Specifically this like this IP and this IP are pretty much very important when you're like doing any kind of infrastructure as code, because you need to create some kind of DNS entry. Oh, speaking of DNS, I guess on one of the future themes I also want to explore how it's called, console, right? So console kind of like DNS for services, I guess. Like you refer to services by their name instead of their IP addresses everywhere. Yeah, okay, I definitely need to explore console. Okay, but this is quite impressive that it caches after we created a resource. It went ahead and created additional parameters about this resource and cached them locally. Okay. In addition to creating resource, Terraform can also make changes to those resources. Add a tags argument to your VM instance. Okay. Where do I put it? Upload. Terraform. Okay, so it says that where is this? Execution. Okay, update in place. Terraform will perform the following action. So this is updated in place. We are updating in place tags. Okay. Yeah, very nice, very nice. Shows like exactly what is going to change and stuff. Very cool stuff, I think. Let's go ahead and verify that it worked. So I guess this tag should be somewhere here. Network tags, dev, web. Very nice. Okay, now, you know what I want to do? Let me edit this and do this, right? Let's see how it performs. Okay, so if I do Terraform show, I think this is queries the, yeah, this is queries cache state. Where is tags? I don't see tags. Here, yeah, this is cache state. Now what happens if I do Terraform apply again? Look at this. So it queried this again and says, okay, I will need to do update in place. I will update this resource, and inside it I will update tags. I will add web. Okay, honestly, this is quite impressive. I actually have another idea that I'm going to try right now. I'm going to change the order of this, because these tags I want to see how it performs. I am evil, ha 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 ha. Ha 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 ha. Okay. So we should see to no, where is my tag? Excuse me? No, not reset. Okay, something broke, I guess. These tags are not updated. Because this is let me do one more time. No, API says that it's fine, but it's definitely not fine. Yeah. No? Okay. It was some kind of browser caching, I guess. Okay, but I still want to do this. So let's see. So the only thing I did, I changed the order of these tags. Honestly, I'm betting I would guess. Okay, my guess is that 80% is that it will see this as the change, and 20% that it's not a change. And the main reason why I say this is because mm, the API will return JSON. I don't know why I'm saying this, but yeah, it would require to very careful coding on like how do you want to compare that the resource is identical or not. It's also possible that in with tags, and I would actually guess, so it seems like I'm incorrect, but I also have a suspicion that it's on Google side. Like you create the tags and then it will just order them in alphabetical order, regardless of how you put them. So yeah, okay. If this is on the Terraform side, that's quite impressive handling all this stuff. Destructive change, the change that requires provider to replace the existing resource rather than updating it. This usually happens because the cloud provider doesn't support updating resource in a way described in your configuration. Okay, this is also kind of big brain thing to implementing a tool like this. So they already like took into account that some APIs just don't allow you to update what you want in place. And in this case, we'll just delete and create that resource. Changing the disk image of our instance is one example of destructive change. Edit boot disk block inside an instance in your configuration. Change it to the following. So there's comment in chat. Next week I'll be making console class service for HashiCorp. Well, very nice, very nice. I hope it will go smooth. So far, I'm actually very impressed by all stuff that HashiCorp builds. Pretty impressive stuff. Okay, so I want to change the boot disk to another image, right? And they say that it is obviously destructive change. So let's see how that will work out. God damn it. I keep yawning and yawning and yawning and it's... I need a decent sleep, I guess. Okay, so we save this and we say Terraform reply again. Interesting. So it says that a lot of stuff is going to be changed. And then we have this minus plus, which says destroy and create a replacement. So all of this known stuff, right? Like IP addresses and stuff will be changed to something we don't know yet, but it will query and know for sure. This is also very impressive. That it can handle stuff like this. This is actually true idempotency. I mean, obviously it's powered a lot by what your cloud provider allows you to do is their API. And usually all cloud providers have very good API and like you can do anything with them. But still, like this kind of tooling around, oh, okay, this resource actually can be updated in place, so we will delete and apply it, but we also tell user about this in very clear form that this is what you should expect if you run this action. Very cool stuff. So my Terraform apply worked. So I guess if we go back to compute engine, there should be like boot disk or something. How do I see a boot disk? Oh, over here, yeah. So it's Debian Buster. If I update this, actually, actually very interesting, because I for a second thought that it will return to us 404, but the way Google API is structured, you see that they don't use ID here. For instance, they use the name of the instance, right? So because they use the name, this allowed this URL to still be relevant. And now we can see that this boot disk image has indeed changed to host, whatever that is. Impressive. Okay, cool stuff, cool stuff. Okay, now if I do Terraform show, I should see again those new IPs and stuff, which I do. Cool. Next, destroy infrastructure. Okay, let's go. You now have seen how to build and change infrastructure. Before moving on to creating multiple resources, sharing resource dependencies, you will see how to completely destroy your Terraform managed configuration. Infrastructure, excuse me. It's a rare event, but if you're using Terraform to spin up multiple environments such as development, testing, and staging, then destroying is often a useful action. Resources can be destroyed using Terraform destroy command, which is similar to Terraform apply, but it behaves as in all of the resources has been removed from the configuration. Okay, this is also very interesting and I would say drastic change compared to something like Ansible here, right? Especially on this destroy front. I mean, there is obviously all these other things, but I want to stop specifically on that. In Ansible, let's say you are managing something, right? I don't know, packages. You need to have them their list anyway that you want to ensure install and or you want to uninstall, right? Like yeah, imagine you are managing a bunch of, I don't know, Linux repo packages. And then, you delete stuff, you add stuff, whatever. And then at some point you want to delete everything, right? You would have to change your state or whatever the parameter is to purge or whatever the module supports. In Terraform, you don't need that because after every action, we keep the state of what it created, right? We can look on our last state file and say, oh, okay, you want to destroy all of this? Fine, I will go through this stuff in my state and just go ahead and delete it because this is what Terraform is managing right now. So very, very cool, very cool. So let's go ahead and do that. Okay, I think we could like move forward. It's not like I don't trust what's going to happen. Terraform applies the order. Terraform determines the order in which things must be destroyed. GCP won't allow VPC network to be deleted if there are multiple resources still in it. So Terraform waits until instance is destroyed before destroying the network. This is also quite huge, right? Like, as part of this provider build, it keeps this sequencing and hierarchy in mind. When performing operations, Terraform creates a dependency graph to determine the correct order of operations. In more complicated cases with multiple resources, Terraform will perform operations in parallel when it's safe to do so. This is huge. I'm thinking if you can see the graph, okay, Terraform graph. Okay, this is also big brain IQ 2000 or 200. Look at this. So we have this root and it says, okay, VM instance depends on VPC network. So whenever I delete the resource, I need to start by deleting VM instance. Whenever I create VM instance, I need to start by creating VPC network if there is one defined. Okay. Wow. Yeah, stuff like this is like I already mentioned a bunch of things, but stuff like the small little details, subtle things, right? This is what really makes a difference between great tool and a bad tool like Ansible. Oh, that was toxic. That was 100% toxic, but okay. Cool stuff. Let's go back here. I know. HashiCorp should probably send me some money or something for me advertising their products so much. Okay, the VM is gone. Oh, this section you will learn more about resource dependencies and how to use resource parameters to share information about one resource with other resources. This page will show a basic example how to configure multiple resources and how to use resource attributes to configure other resources. If you have been following this track, you destroyed your resources in the last guide, and so Terraform show will show no resources. Okay, let's go and work. Yep, nothing. Now let's recreate. Now add to a configuration by assigning a static IP to the VM instance in main here. This should look familiar from earlier example of adding VM instance resource, except this time we are creating a group compute address resource. This resource type allocates a reserved IP address to your project. You can see that this will be created with Terraform. Okay, this is, I think, where it will get a little bit more interesting. So remember I told you, like, I showed you this stuff with IP addresses. Google, like, if you say that you just want an IP address, it will just select one, I guess. But you might have some kind of control over that, if I remember correctly, and I think this is what we'll be doing right now. So you will first create an IP address. It will also be like from the pool, but then you save that, I guess, as a variable, and you will use it in different place. I think this is what this is going to do. Okay, so Terraform plan will show only what will be changed. Okay. Okay, so it says, so it went ahead and queried Google API and said, okay, if you are to do apply, this is what it's going to do. It will create a new resource and there will be some these other parameters. Okay, next you need to attach IP address to your instance. Okay, so as I said, I saw where this was going. So we create this IP address from the pool and like we kind of save it and then we can refer to it in a different place. Okay, so first let me there are two pieces here. So network is self-link. I don't know what this really means, but there is here another IP address. Okay, so where is this coming from, right? So I guess if we were doing Terraform plan, right? So we are going here to this provide direction or whatever that is, provide the resource, right? To the resource named VM static IP, and then you'll get IP address here, which is going to be added here after we apply. Now, because we have Terraform graph, this dependency should be somewhere. Yeah, and I think this is here. So VM static IP depends on provider Google. Now VM instance should it depend? I thought it should be depend, but maybe not the case. Okay. Okay, I guess you can attach IP addresses later. So that's why it's not needed. When Terraform releases configuration, ensures that VM static IP is created before VM instance. Oh, okay. This dependency is not needed per provider. This dependency is needed per Terraform because we are referring to this parameter which we'll know later. So it says, okay. I don't know this parameter yet, but I needed to create the VM. So I will first create this resource and then I will create this resource based on this IP address. Quite huge stuff. Okay, so Terraform one. Oh, out static IP. Okay, so it says here, interesting for me. Oh, I didn't set the file again, god damn it. Okay, so we will be creating a VM static IP resource, and then we will be updating in place the instance because this instance is already running, right? And we want to change. We want to change where this is. Don't see it. Oh, here, right? We'll be changing the IP address to the static known after apply. Interesting. How does it know? Oh, okay. I'm stupid. a little bit stupid. So this is what is already there on the machine, right? But then it will change to that IP address that we create from the pool. Okay. And then if you save it, you can just provide the name Terram. Yeah, this is exactly what I was talking about. So based on this expression where we are referring to the variable, it knows, aha, okay, because I have this reference and I will be doing this stuff in the particular order. Okay. So this, because of this variable stuff, we have implicit dependency, but you also have like provider dependency, if that makes sense. So like something should be created other than, before then. Sometimes there are dependencies between resources that are not visible to Terraform. Depends on argument can be added to any resource and accepts a list of resources to create explicit dependencies for. Okay, so I think this is similar to what you find in Docker Compose or something, where you say depends and you provide a list of other services it depends to. Because sometimes, depending of like how your dependencies are expressed, then you may need to add it yourself, which I think this is what they will be showing right now. We are only on our 30 minutes in and I'm already tired. um, but I still definitely want to try it with ASA. Like I just want to see how it applies the stuff to firewalls. Okay, so we add a cloud storage bucket and an instance with explicit dependency on the bucket by adding the following to the main TF. Oh, here we go. Okay, let's see what's going on here. Okay, so new resource for the storage bucket all application will use. Uh, Okay, so here we say that we'll create this instance only after this is created. I mean, this makes total sense to me. Google storage buckets must be globally unique. Because of this, you will need to replace unique bucket name with a unique valid name for a bucket. Okay. This bucket is fine. Yeah, probably date would be useful as well. Kudos to them for putting the date in freaking best format ever. Because the whole world like, oh, we use date in this format, we use date in this format. This is true programmatic way to express dates. This is what I'm talking about. Okay, so let's go do Terraform. Do I need init? Oh no, I just need plan. Oh, of course I didn't say this. Okay, we'll be creating a bucket here. How many lessons we have left? I think we are almost done here. Oh no, it's still a bunch. Let me see what else. Variables, output variables, next steps. Revision 10, 10, 5. Okay. I think we could finish this and then I will try essay and we will wrap up. Okay, compute instance will launch to this point based on Google image given but has no additional software installed or config apply. GCP allows customers to manage their own custom operating system images. This can be a great way to ensure the instances you provision with Terraform are pre-configured based on your needs. Packer is the perfect tool for this and includes a builder for GCP. Okay, so for those of you who don't know Packer, and by the way, I also have never used Packer before, I just heard about the tool. It's a way to build an image that can be deployed somewhere else, pretty much. Like portable VM, if that makes sense. So now we recommend is a tool like Packer. Well, of course you do, because it's another tool you developed. I mean, nothing wrong with it, but still. So that your infrastructure requires little to no provisioning after it's deployed. Managing your infra this way, sometimes called immutable infrastructure, can help ensure your infrastructure is more robust and fault tolerant. So many infrastructure still require some sort of initialization or software provisioning step. Terraform uses provisioners to put files, run shell scripts, or install and trigger other software like configuration management tools. Okay, so let's talk about this a little bit. Yeah, mutable infrastructure, this term you can hear a lot in DevOps world. Um, it's it's a way to kind of like yeah, represent your infrastructure as code which is version controlled and allowing you to jump between different like states of your infrastructure very simple. So for example, we already saw this example. Like I could destroy all of this, right, and recreate it in just blink of an eye. Like I wouldn't go to GUI or something. I don't write my own scripts here to do this. Like a lot of the stuff is built for me. I just say, oh, okay, I just want to destroy everything and recreate it. You could literally do this in 1 minute, no problem. Um, this kind of stuff where you can easily blow up your infra and then recreate it. This is like one of the key features of immutable infrastructure. Okay, so in this case they say, okay, but just spinning up VMs is cool, but you probably want to do something on those VMs. But for example, even if you use Ansible to manage packages there, right? Like you need to have Ansible installed there. Do you need to have Ansible? Yeah. Wait, hold on. Do you need to? Yes, you need to have Ansible installed on your machine that you are controlling, or any other configuration management tool like Puppet, Shell, whatever. Like you need to have them installed before they can do their thing. So I think this is why they have this provisioner, which allows you to do something on those VMs to provision them. Okay, let's define a provisioner. Modifies the resource block, defining the first VM instance in your configuration to look like the following. Okay, before we do that, let's see what happened here. Okay, we created, so we need to have now 2 VMs. The song is not great, I think. Something didn't work out so well. Excuse me? Oh, yeah. Yes. Ansible doesn't work through SSH, but it's still... Wait. It does work through SSH, but for servers, you still need to have it installed remotely, no? Ansible, do you need Python installed on control posts? Yeah, okay. You just need Python. I guess the yeah, okay. Actually, this one something that is interesting. While installing Ansible, sometimes you may encounter no package, blah 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 blah. No, this is not what I'm looking for. Yeah, I guess if we have SSH and we have Python remotely, we could install all dependencies locally, package them together with your code, right, and send it by SSH for remote execution. I don't remember. I think this is the case. It has been a long time since I've been using Ansible, but You can bootstrap the Python installs on the remote machines for Ansible using the SSH module, if I'm not mistaken. Yes, except you don't even know an IP address, sir. You are not even sure that SSH is even enabled in your provisioned machine, right? So the functionality, it seems to me that functionality of these tools like Terraform definitely intersects a little bit with something like Ansible, because you obviously can create virtual machines with Ansible as well. But it does provide you that level of granularity and true idempotency on the creation side of things of that infrastructure. But the like provision and creation of resource really goes hand in hand, because you create a resource in some cloud provider and you need stuff like, oh, I need its IP address, I need to have, I don't know, SSH enabled, I need to, I don't know, Docker installed, right? Some of the stuff you would obviously probably put in your VM image in the first place. So you would probably like build your image and with like, I don't know, SSH already installed and running, and Python or Docker, whatever you want to run, right? And then you would refer to that image as this is what I'm deploying. But you still need something like at least IP address, right, to refer to it. So yeah, it's kind of like they're intersecting, but also not 100%. Okay, and we see it here in another instance that was created. And we should have also bucket. If I could remember, it should be somewhere in the top level. Data store? No. Storage. Fire store? Ah, Jesus Christ. File store? This API is not even enabled. Okay, instance, snapshot, TPU, metadata, health check zones. Compute. I don't see it here. No. App engine, no. No. Should be somewhere in storage, I think. Tools. Container registry, deployment management, endpoints. Source repo, big data, no. AI, no. Should be in storage. So, storage, browser. Google storage bucket, example bucket will be created. Test bucket 2020-06, and then bucket was created, and then instance was created. Here. Where is this? Oh yeah, okay. It's in storage in the browser, and then there is a bucket. Okay, cool. So let's go back. Define a provision. I think I didn't do this. And yeah. Okay, so local exec will be executing command. Oh, and here we also can refer to the some of the stuff. So we will print. So you have VM instance name. So this one, Terraform instance, printed with instance network interface. network interface 0. Actually, this is something that I don't think I like. So you see that I think with the syntax, you both define a single element and multiple elements. Because you see here like the square bracket 0, right? Like they don't distinguish between list of things and kind of like nested things, like dictionary like. This looks kind of weird. And then we'll just save the VM name and the IP address to the file. Kind of like etc hosts, I guess, ish. And then we should be able to see it. Okay. This adds provisioner block. You can have multiple steps. Okay, so this is like Pursman configuration management, I guess. Okay, and they say if I do Terraform apply, nothing will happen. Terraform treats provisioners differently from other arguments. Provisioners only run when the resource is created, but adding a provisioner doesn't force that resource to be destroyed and recreated. Use Terraform taint to tell Terraform to recreate an instance. Okay, so interesting stuff. Then the resource will be destroyed and recreating during the next apply. I like the term that they use taint. Okay, so they will create stuff and then they will run a script. Verify everything worked by looking at the contents of IP address 60 file. I mean, this is great, but first you have to access the instance, which I'm not sure I can actually do. No, I should be able to. Engine and instances. Okay. So I think it should work. And then connect. I think I had some issue here. Does it have a public IP? It does have a public IP, but it doesn't. Doesn't matter because I don't think there is SSH enabled on that instance. Oh, and I don't even have Google Cloud CLI installed on this machine. That's a F. Oh, yeah. I may need to do that. Wait, how do you do that? Sage is usually not enabled by default. Is there a security group on the instance which is blocking the port 22? Yeah, I think this is it. I mean, actually the rules here. One second, folks. Right. Oh, it's App Engine. No, this is correct. Okay, I think we could try again. This is kind of weird that SSH is not working. Yeah, that's not great. What is going on here? Yeah, this not necessarily will work. Since I don't think, I don't know. This is weird. Wait, what? Excuse me? Is it on VPC level? Oh, okay. I don't know what it is. It was applying to default VPC, but not to the my VPC. God damn it. Let's go. Okay, I mean, this is kind of expected because I don't have the public key there, but at least I should be able to go to SSH via the console. Okay, that was some nice troubleshooting, I guess. Like, I can't even make SSH to work. What the hell is going on here? Yay! Yay! So you should have the file called it. Excuse me? Excuse me? Wait a minute. It could be in the. Can it be in the root? Okay. Where do I find this file now? I mean, there are no folders here. Cronus. Would it be Cronus? Invokes local executable after resource is created. This invokes a process on a machine running. Wait, excuse me? This invokes process on the machine running Terraform, not on the. Oh boy. Okay. There is wrong remote exec. Okay, I see. Okay. Okay, it's over here. Okay. So this is, yeah, this runs locally on my machine. But that's actually, I mean, this is pretty nice use case, right? Because we got this mapping of our resource to an IP address, right? So then we can, I don't know, in the worst case, we can generate our ITC hosts, right? Or we can create a new config file for DNS server. Or we can use console or something, and I guess this something like this would feed into console. Yeah, okay, that's pretty nice. But I for a second I was like, where is this file? So it's good I went to this page to understand where it's coming from. Resources successfully created but fails provisioning step. Terraform will error and mark the resource as tainted. Resource that is tainted still exists, but shouldn't be considered safe to use since provisioning failed. Okay, this is also something like also quite interesting. See, whenever we talking about like all this idempotency and stuff, even with the most perfect API ever, right? Like that allows you to modify every single resource the way you want or whatever, blah blah blah, right? There's still rooms for errors, like something breaks, in this case provisioning breaks because I don't know, script is incorrect or something. Don't care too much, but it may happen, and it happens more often than you think. And your kind of like resource is in this unknown state to the tool, if that makes sense, right? So what do you do with this, right? And they said, okay, we are going to we are going to use this tainted thing. 3 branch, thank you for following. We'll use this tainting to kind of mark this resource that, okay, something is working here, potentially. And then you could use, I guess, if you do Terraform apply again, it will recreate it. When we generate the next one, Terraform will remove any tainted resources and will create the new resources. So you kind of like know that, okay, the resource, something happened, so you may go ahead and change your script and then try again. You don't need to destroy anything, you can just reapply your Terraform apply, right? And it will, because that resource is tainted, it's going to be deleted and recreated. Provisioners can also be defined to run only during a destroy operation. Those are useful for performing system cleanup, extracting data, etc. Yeah, something like cleanup is also like big problem with any kind of idempotency. I already discussed this slightly with packages, with, you know, when you, I don't know, do apt install something, right? Like in Ansible, for example, you have a list of packages defined, but then what happens if you know, if you just delete the file, right? Like nothing will happen because you need to ensure that you have that purge keyword or something, state purge or whatever. All this cleanup is also like a big trouble in all this desire to be idempotent. Okay. This guy doesn't have any examples on this. It's fine. That's fair. Okay, input variables. We have enough knowledge. First, let's convert a few hardcode values into variables. Let's create another file called variables tf with the following content. Okay, this is cool. I like this kind of separation. So let's do constants tf, and we move all this. Terraform loads all files ending in tf in the directory, so it doesn't matter to Terraform where your variables are defined. We recommend defining them in their own file to make your configuration easier to organize and understand. Perfect. This file defines 3 variables within your Terraform configuration. The first one has an empty block, the other 2 set defaults. If a default value is set, the variable is optional. The default value is set, the variable is optional, otherwise the variable is required. If you run Terraform plan now, oh, I see. That's actually also quite interesting. So what this gives you, right, is, say if you do Terraform plan now, so you have like some default values for variables, but for this one we are going to be, didn't work out. Oh, I didn't save it, of course. So now it says, oh, okay, give me a value for credentials files, right? I can say a.json. And then for the project, I can say, I don't know. I mean, I will need to obviously be precise, but whatever. Okay. Cool. So next, update your GCP provider in the main TF to use these new variables. Okay, go ahead and do that. Hold on. I need to save this path because I usually need to have it. And then this one as well, right? Okay, so now we are referring to these constants, right? Region, zone, project, credentials, file. Okay. So now, if I do Terraform plan again, we are getting asked about all this stuff again. And you know what? Hold on. I guess if I put description here, description help. I think this will work, I don't know. Yeah. Very good. Okay. This still works. Amazing. Amazing. Assigning variables. There are several ways to assign variables depending on your needs. You can set variables directly on the command line with a var flag. Okay, let's do that. You can put it in the file. These TF vars. You know what we'll do? We'll use both. Oh. Ouch. Okay, this works. So I have one variable on the command line and one from a file. You can create local secrets. I'm missing the recommendation to use HashiCorp Vault. Okay. Okay, you can have variable, environmental variable, TF var and the name of the var. defaults, variable types, strings. If no type is specified, then we assume it's a string. We can have a number. We can have lists. Very nice. Maps, like a dictionary. Type map. Subject maps. Or machine types. Okay, let's try this one. Terraform one. Oh, yeah, I need to put it here. Okay, nothing should change. Okay. Because we have environmental in dev, and then we have machine types. For dev, we are using a one micro, and we say machine types dot, what's the syntax? Machine types square brackets var dot environment. Machine types square brackets var dot environment. Looks good to me. What else is here? To be honest, I'm kind of like, it's already details that I'm not sure I need. Map, you can also set maps on the command line. Yada, yada, yada. You can also put this into vars if you want them. Yeah, whatever. Okay, let's define an output to show us a static IP address that we created. Create a file called outputs.tf is the following content. Okay, output. Okay, so you'll see an IP address of the VM created. Just like variables TF, this configuration could go in your main TF, but you put everything differently to separate, like make it more organized. Value, public IP address, attribute of the elastic IP address. Okay. Run Terraform refresh. This will refresh your state by comparing it to a cloud. Okay, so this is also quite interesting, right? So when you do show, so if you do Terraform show, it just shows what is currently in the cache, right? But if I do Terraform refresh, we make sure that this cache is updated. Okay, it's 2 hours 30 minutes. Yeah, I'm kind of tired. Oh, of course I didn't save the file. Why would I save a file? Okay, and then you get an IP address. Very nice. Cool. Next steps. So now you can destroy the stuff. Very cool. So yeah, this was very cool demo, very cool quick start guide. I enjoyed it, and I see the power of this tool. It's not. We'll do one more thing right now. We will try it with ASA, I guess. Yes. Okay. So I guess I will have to. Well, I did a mistake, didn't I? I definitely did. So, and my mistake is that I didn't put it in a separate folder here. So this will be GCP, right? And you take this and move it there, take this and move it there, and then let's do ASA. Okay. And I will just do very simple example because, you know, to be honest, I want to wrap up, but I also want to make sure that this works. Like I think it should work. Okay, so GCP, let's take what? Let's take this one. Okay, so first let's go ahead and create the lab. If only I could remember the IP address of this. Wow. Okay, and we create a lab, ASA, and let's put a router, ASA, and another router. What was this small? And another router here. Let's connect it. Oh, I need outside network as well. So external connector, which should be bridge. We connect this to management. And then here we connect 01 to 00. And we start this lab. We'll have to configure some IP addresses here. Let's make this one outside. So this one will be 29165.200.11, and this will be 100/24, and this will be some internal network. Probably 10.0.0, I guess. I'm not sure what Cisco site you're referring to, man. Source Q Legend, hello, how are you doing? It's not a site, it's a simulation tool. just a GUI for the tool. But I don't know, if you don't like it, man, you don't have to use it. I'm a web designer, I critique stuff. Okay. Okay, so this is going to be R1, and we will say that we just need an IP address, don't we? And I think it was gigabit 00, so with no shot and IP address 10, 0, let's do 12. Oh, what happened? Yeah. Circuit address 10, 0, 12, 1. And let's do /24. And we will go here as well. But first we need to make sure that there is connectivity. I don't remember though if ASA will allow pings. It's been a long time since I have been using ASA. And okay, so show interface AP brief, or how to, yeah. I still remember something. No. Show interface AP brief. Interface management 00. Okay, so here I need to be quite careful. I don't remember what is the subnet for this. Let's do that 101, I guess. One 192.168.153 101/24. Oh no. Yeah, it's mask. Okay. No shot. Okay. I don't think that it will allow pings, but I may be mistaken. Okay, fun. Let me disable my firewall because I was recently enabling the firewall. And I hate this. I just want the proper. Can you give me, please, everything? No. No. This one. Still no go. But again, I also don't remember. Oh, no route. No route. Wait, what do you even mean no route? Is it in VRF? You can manage ASA by connecting to any through traffic interface dedicated management 00. You can use any interface as dedicated management interface by configuring it for management traffic. See management only configure command. Management interface for transparent mode. In transparent firewall mode, in addition to stuff, hello, what are you looking at? I'm trying to understand the basic minimum configuration required for ASA so I can manage it from a remote machine. And unfortunately, I don't remember anything about ASA because the last time I was using it was 3 years ago. Another thing that bothers me is that I cannot ping ASA management. Just there is no route. No route whatsoever. Is there ERF? ERF? How about we do it reverse? Which of course doesn't work as well. I will try a little bit more. If I don't see a good way to deal with this, then I will just you may need to enable ICP inspection. Okay. No name if management only security level 100. Yeah, let's do that as well. I don't remember if I actually need security level on the management interface, but let's do this anyway. So let's do management only, which I think is default command on management, and we will do security level 100. Yep. So, and then they suggested that I have to enable a CP inspection. Okay, and now I mean, there's still no route though. Line protocol is up. There are input packets though, so this is a good sign. Maybe now from remote machine this will work. Which it doesn't, of course. What I have here? I have breach, so this should be fine. Let's do one more thing. So let's remove this. And we will add a managed switch. And then we will put like this, and I need to make sure that it's breach, and I should start this. This doesn't look good. Doesn't look good at all. Okay, so this machine is .99, then ASAv is 101, and my Ubuntu server is 100, so I think it should be fine. This is a relevant meme. Okay. Oh. Oh. Well, this is on outside network. Can I at least do one inside? Okay, I can ping inside. So I guess if only I remembered how do you even do this. I think not one source dynamic. I just don't remember. This ping though kind of throws me off. Where the username? Let's also do name if. And let's do what SSH. Management. Okay, so if I did everything correctly, which doesn't seem to be the case right now, this should work. No route to host, excuse me. Okay, folks, I'm not in the mood right now to troubleshoot ASA. I'm definitely doing something correctly. Right, I think we will wrap up for today. Since like I wanted to explore Terraform with ASA, but doesn't seem to be like it's going to happen, which is fine. So yeah, let's do summary on Terraform. So we have looked today at Terraform. This was my very first experience with it, or I've never used it before. I've never, like, none of from my colleagues ever showed me this tool, or like what you can do with this and why. That all said, I was very impressed by the tool. I think it's very well built. It is really focused on this immutable infrastructure deploy, especially if you're using any cloud services. It seems like its primary use cases for the cloud, though there are some things that you can do outside of the cloud. And we were going through their guide where they were showing how to use it with GCP, with Google Compute Engine, Google Compute what project, whatever, Google Cloud, so Google Cloud stuff. So Google Cloud Platform, yeah. And yeah, a lot of stuff was very impressive, very well thought. I like what I saw. I definitely see good use cases for using this. It really like keeps the state of what is going on and make sure it is up to date with what you want it to be. And if something is not correct, it will try to update it, and if it can't, it will recreate something. Very, very impressive stuff. Yeah, I I would give a thumbs up for the tool. I would encourage you to check it out if you have a need to deploy at least cloud services, though it seems like at the very beginning we were looking at some other providers that they have. Like you have some DNS stuff there, you have some VMware stuff, you have some stuff with like ACI, load balancers, and firewalls. This is what I wanted to do at the end, but you kind of, stumble upon problem that I don't remember anything about ASA, what is needed to make it work. So like we spent 20 minutes and we didn't get anywhere that far. So I guess, I dropped this idea to apply it to the firewall, which is fine. Like I need to figure out what do I need to configure an ASA to make it work on my network correctly. But yeah, it's kind of on a tangent here. The Terraform itself, very impressive. All the stuff is keeping the state and tainting the nodes and yeah, stuff like this. I really liked it. If I ever have a need that I am the one who is responsible for cloud infrastructure, I would definitely use Terraform. All right. With that, thank you so much for stopping by, and I will see you next time. Goodbye now.